When an archaeological team unearths a relic that aggressively contradicts every established historical timeline, their first reaction is rarely celebration. Their immediate response is intense, paranoid skepticism. In the rigorous discipline of the scientific method, an outlier of massive proportions is typically assumed to be a technological glitch, a calibration error in the equipment, or an elaborate optical illusion generated by environmental factors. Recently, a coalition of international astrophysicists utilizing the unblinking eye of the James Webb Space Telescope stumbled upon a glowing red speck buried deep within the cosmos legacy field. The preliminary data attached to this tiny cluster of photons was so violently opposed to our fundamental understanding of early cosmic evolution that the scientists literally named their follow-up investigation the Mirage or Miracle survey. They needed to ascertain whether the cosmos was deploying a complex gravitational lens to play a cruel trick on their state-of-the-art mirrors, or if they had genuinely captured a physical impossibility. The definitive verdict has just been published by researchers at MIT's Kavli Institute, and it is, without a doubt, a miracle. Officially designated as MOM-Z14, this ultra-luminous, highly compact entity has seized the crown as the most distant confirmed galaxy ever observed by our species. Residing a staggering 280 million years after the Big Bang, MOM-Z14 has entirely upended the cosmological playbook. Today, we delve into the deep thermal abyss to examine a galaxy that grew far too fast, burned much too bright, and possesses an anomalous chemical signature that is currently forcing researchers to completely rewrite the origins of heavy elements. To fully grasp the magnitude of the MOM-Z14 detection, we must first navigate the severe mechanical hurdles of viewing the infantile universe. Light, despite being the fastest entity in existence, requires a tangible, quantifiable amount of time to cross the cosmic void. The ancient photons that struck the beryllium detectors of JWST's near-infrared camera embarked on their harrowing journey 13.53 billion years ago. They were emitted during the reionization era, a chaotic, pivotal epoch when the suffocating, opaque fog of neutral hydrogen gas that filled the early universe was just beginning to be burned away by the intense radiation of the very first luminous bodies. However, traversing 13.53 billion years of time does not mean the object is 13.53 billion light-years away today. The underlying architecture of reality is governed by continuous metric expansion. As the light from MOM-Z14 traveled toward Earth, the physical fabric of space underneath those photons was actively stretching. This spatial dilation engine acts as a relentless multiplier. By the time the light finally reached our orbital sensors, the physical coordinates of that galaxy had been pushed outward to a mind-bending, proper distance of 33.8 billion light-years. This relentless stretching also inflicts a severe penalty on the light itself, a phenomenon known as cosmological redshift. The energetic, high-frequency ultraviolet radiation emitted by the young stars of MOM-Z14 was stretched so viciously that it dropped completely out of the visible spectrum. When JWST's near-infrared spectrograph analyzed the target, it confirmed a record-shattering redshift value of Z equals 14.44. The research team confirmed this exact distance using a highly specific astronomical fingerprint known as the Lyman break. In the early universe, thick clouds of neutral hydrogen absorb almost all light at wavelengths shorter than the Lyman limit. When astronomers look at the spectrum of a distant galaxy, they see a sudden, sharp drop-off in light, a literal cliff in the data. By measuring exactly how far this cliff has been shifted into the infrared by the expansion of space, they can calculate the exact age of the light. At a redshift of 14.44, observing this galaxy is like trying to decipher a faint whisper through a solid titanium wall. Yet, despite the staggering degradation of its light, MOM-Z14 did not register as a struggling, dim whisper. It registered as a blindingly luminous beacon. The sheer, unapologetic visibility of MOM-Z14 is the primary catalyst for the current theoretical crisis in astrophysics. Prior to the deployment of JWST, theoretical supercomputer models dictated a strict, gradualist approach to galaxy formation. The early universe was presumed to be a sluggish, highly disorganized environment. Gravity was expected to require billions of years to slowly pull together diffuse gas and dark matter to form coherent, bright galaxies. MOM-Z14 blatantly violates this gradualist doctrine. The spectroscopic data reveals an extraordinarily compact and violently luminous object. Its effective radius is mathematically confined to a mere 241 light-years. For essential context, our Milky Way galaxy spans roughly 100,000 light-years in diameter. MOM-Z14 is roughly 1% the size of our home galaxy, yet it is absolutely packed with a stellar mass of approximately 100 million suns. This is a compressed genesis. The extreme density of star formation required to pack 100 million solar masses into a 241 light-year arena within the first 280 million years of the universe is staggering. It resembles a hyperdense, high-pressure stellar incubator operating at absolute maximum capacity. To understand how radical this is, consider that the small Magellanic Cloud, one of our galactic neighbors, contains about 3 billion solar masses but is spread out over thousands of light-years, and it had over 13 billion years to evolve. MOM-Z14 achieved a significant fraction of that mass in a physical space hundreds of times smaller, entirely within the first 2% of the universe's lifespan. Standard hierarchical models simply do not account for a dark matter halo acquiring this much baryonic matter and triggering such a violent, localized starburst so early in the cosmic timeline. The surrounding environment was supposedly too hot, too diffuse, and too young to forge such a highly concentrated metropolis. Yet, the physical evidence is indisputable. The galaxy exists, mocking the slow growth timelines we previously held as absolute truth. If the structural density of MOM-Z14 fractured existing cosmological theories, its internal chemistry shattered them completely. When astrophysicists dissect the light of an ancient galaxy using spectroscopy, they are essentially hunting for the elemental byproducts of stellar evolution. The infant universe was a chemically sterile environment containing only hydrogen, helium, and trace amounts of lithium. All heavier elements must be synthetically manufactured within the nuclear furnaces of massive stars, and subsequently dispersed into the interstellar medium upon their explosive deaths. When the Mirage or Miracle team analyzed the specific emission lines of MOM-Z14, they did not just find the expected, standard traces of early stellar death. They encountered a severe chemical mutiny. The data showcased an overwhelming, highly supersolar abundance of nitrogen relative to carbon. This specific nitrogen spike is a profound cosmological puzzle. In modern astrophysical frameworks, producing such an extreme ratio of nitrogen requires incredibly specific nucleosynthesis conditions. Standard massive stars, operating on normal timelines via the carbon-nitrogen-oxygen cycle, cannot generate this massive imbalance in a mere 280 million years. This unprecedented discovery forced researchers to propose a radical, or inspiring solution: the presence of supermassive stars. To generate this unique nitrogen footprint, the dense, hyperpressurized environment of MOM-Z14 must have birthed individual, colossal stars weighing tens of thousands of times more than our Sun. These hypothetical titans would have burned with apocalyptic fury, rapidly synthesizing massive quantities of nitrogen in their cores before collapsing directly into intermediate mass black holes, bypassing the traditional supernova phase. Furthermore, this specific chemical abundance pattern perfectly mirrors the anomalous composition found in the oldest globular clusters currently orbiting our very own Milky Way. We are not just looking at a random chemical oddity in the deep void, we are potentially witnessing the exact, extreme environmental blueprint that birthed the oldest, surviving relics of our own galactic backyard. Astrophysics has officially merged with deep-time archaeology. The flawless conformation of MOM-Z14 serves as a formidable reminder that our understanding of the universe is still in its absolute infancy. The cosmos did not wake up slowly, it ignited with a fierce, hyper-efficient brilliance that we are only just beginning to comprehend. By linking the nitrogen-rich fossils hidden within the Milky Way directly to the roaring, supermassive starbursts of a highly compact galaxy 33.8 billion light-years away, we realize that the ancient, early universe is intimately connected to our present reality. The heavy elements currently drifting through our home galaxy were likely forged in extreme, compact crucibles exactly like MOM Z14. We are standing on the precipice of a new cosmological era, where every deep field image threatens to rewrite the textbooks we considered settled only yesterday. Do you believe these hyper-dense, nitrogen-rich galaxies are the standard precursors to all modern structures, or is MOM Z14 a rare, extreme mutation of early cosmic physics? Share your most rigorous theories and perspectives in the comments section below. If you are relentlessly driven to understand the outer boundaries of the cosmos and the mysteries that challenge the very laws of physics, secure your place in this community by hitting the like button, subscribing, and activating the notification bell. The deepest corners of space are finally surrendering their secrets, and we will be here to decode every single one of them.